Okay. So, this will be first of the 3 lectures on Ganita Kaumudi. So, 2 I will be giving. So, this is the outline where I will first talk about the importance of Ganita Kaumudi, then some important topics here: solutions of quadratic equations, double equations of second and higher degree, rational solutions, then determinations pertaining to mixture of things, then interest calculations, payment in installments. There are some interesting methods which are given here, which are relevant even today. So, Ganita Kaumudi was composed in 1356 Common Era by Narayana Pandita, as indicated in the final verses of the work. So, it is not clear where he was born or where he flourished. It was this work was edited and published by Padmakar Dwivedi in 2 volumes based on a single manuscript which belonged to his late father, the legendary Sudhakar Dwivedi, in 1930s. Sudhakar Dwivedi was a very famous person who edited and translated many of the important works in Indian astronomy and mathematics from 19th century onwards. He was one of the persons who was involved in the revival, important persons in the revival of interest in the Indian mathematics and astronomy. So, Padmakar Dwivedi is his son. There is another work of Narayana Pandita called Bija Ganitavatamsha. Only the first portion of this has been published and based on a single and incomplete manuscript at Benares. So, Ganita Kaumudi has been translated by Paramananda Singh, one Paramananda Singh, with explanatory notes. It was published in these volumes of Ganita Bharati. There is a journal of Indian mathematics, history of mathematics. History of mathematics could include mostly Indian, but others, this thing, history of mathematics in other cultures also is there in this. So, it is completely devoted to that history, and he published this between 1998 to 2001. So, it is a very big work. After Bhaskara II, there are 2 major developments in Indian mathematics. So, this is the one, Narayana Pandita's Ganita Kaumudi, and other is the Kerala School of Mathematics and Astronomy, mainly during 14th and 17th, between 14th and 17th centuries, wherein calculus concepts were developed. You have already heard a little bit about it. You will hear it in more detail in the lectures to follow. So, Narayana Pandita carries forward the tradition of mathematics in India substantially. So, there are more formulae, generalizations of earlier results, and systematization. So, in fact we had seen it, from Brahmagupta, Sridhara and others carried it forward, including of course Mahavira, whose work Ganita Sara Sangraha we discussed. So, then it was carried forward more by Bhaskaracharya in his 2 works, Bija Ganita and Leelavati. So, we saw that there are many advancements in that compared to the earlier works. So, similarly here also Narayana Pandita carries forward, he introduces more advances, and he, in fact it is this thing is, the aim is to suppose there is some result earlier, can I say something more about it, can I generalize this result. That seems to be the way he seems to be working, and that is the way it is written. And especially there is a big leap in the treatment of combinatorics and magic squares in chapters 13 and 14. Of course, other things are also there. There is a substantial improvement in cyclic quadrilaterals, then rational figures and so on. But and one more very important result about the kth sum. You see, if you carry out the sums of integers, first sum, second sum, we already discussed it, he generalizes that. So, apart from those things, the major results are contained in chapter 13 and 14, so which will be dealt with by others. So, it is meant to be a comprehensive text covering most of the prevalent mathematical knowledge in India at the time of composition and making substantial additions to it. Okay. So, I will give a brief summary of the 14 chapters in this work. So, chapter 1 is on measures of weight, length, area, volume, capacity, etc., as in other works. So, there are 8 operations, we saw it in Leelavati also: addition, subtraction, multiplication, division, square, square root, cube, cube root, so they are described, and solutions of more complex linear and quadratic equations are discussed here, because simpler things had already been discussed in earlier works, and so he is thinking to generalize them more and make it a little more complex. And chapter 2 is an Vyavahara Ganita, or mathematics pertaining to daily life. So, a calculation pertaining to mixture of materials, interest and principal, payment in installments, mixing gold objects with different purities, and other problems pertaining to linear indeterminate equations for many unknowns, they are considered, and there is lot of progress compared to earlier treatments. Example, I will take this interest calculations where payment by installments are considered. I will deal with it a little in detail. Then chapter 3 is an arithmetic and geometric progressions, where the concept of sum of sums is generalized to the kth sum of the first n integers for arbitrary k. So, we had already seen that Aryabhatta himself had given the sum, you see. So, sigma 1 plus etcetera n, sum of first integer n integer, that is n into n plus 1 by 2. Then if you take r into r plus 1 by 2, if you sum 1 to n, so that is the second sum. So, like that you can go on. So, he has given the formula for the kth sum. It is a very important generalization which is needed for finding infinite series for sine and cosine functions, among other things. So, that will be discussed later, how it is used and how exactly does it figure. Chapter 4 is on plane geometry, where properties of triangles, quadrangles or quadrilaterals, circles, cyclic quadrilaterals etc. are considered. Now, he introduced a new concept called a third diagonal associated with a cyclic quadrilateral, and then area and circumference of the cyclic quadrilateral are discussed. Then chapter 5 to 8 they are on 3-dimensional geometry, where rules for solid figures and capacities of excavated volumes are presented. Then chapter 9 is on Kuttaka procedure for solving linear indeterminate equations of first degree. Of course, I will not deal with it, already it has been done in detail. Then chapter 10 is on quadratic indeterminate equations or Varga Prakriti, so which was done earlier, I mean yesterday here. Here a variant of the Chakravada procedure of Jayadeva and Bhaskara is also considered. Yesterday it was mentioned that when you are going from one step to another, this Pi will come, the auxiliary quantity, then you have to choose it such that mod of Pi plus 1 whole squared minus d, so that is minimum. So, there is a small change here that Narayana Pandita considers, and you know that Chakravada procedure is due to Jayadeva and Bhaskara, small change is there. Okay. So, then chapter 11 and 12 is on divisors of a number and fractions. Then chapter 13 is called Anka Pasha or combinatorics, partitions of numbers, sequences of binomial and polynomial coefficients, and various merus. So, I will not be doing much, but little bit I will do, little bit in this I will do, but it will be done by others. Then chapter 14 is on magic squares, and so basically I will do pertaining to chapters 1 and 12 in what follows, 1 to 12 in what follows. Okay. So, in chapter 1 I will just discuss some important things only. This is not a comprehensive lecture giving the content of Ganita Kaumudi comprehensively. Whatever important thing is there, I will try to emphasize that. See, for instance, after discussing 8 operations, various simplifying manipulations involving fractions are discussed, and in the earlier text Sankramana I already mentioned. So, that is, if the sum and difference of a number are given, you can find the number. So, this is Sankramana, x plus y is equal to a, x minus y is equal to b, then x is a plus b by 2, x is equal to a minus b by 2. So, in Ganita Kaumudi, problems which can be reduced to Sankramana are discussed. For instance, suppose you are given x minus y is equal to b and x squared minus y squared is equal to a. So, then you can find x plus y is equal to x squared minus y squared by x minus y is equal to a by b. So, x and y can now be solved, as we know both x minus y and x plus y. X minus y is given and x plus y we have found out. Similarly, suppose you are given x squared minus y squared and x plus y, x minus y can be found out similarly, and you can solve it by Sankramana. Then little more non trivial, varga samasat dvigunat antara vargonitat padam yogaha. The square root of the difference between twice the sum of the squares of two numbers and the square of their difference is their sum. So, now suppose you are giving x minus y is equal to b, x squared plus y squared is equal to a. So, then x plus y, one can see that it will be 2a minus b squared, and you can solve it by Sankramana. Similarly, suppose getting more and more this thing difficult. Suppose you are giving x squared minus y squared is equal to a and x squared y squared is equal to b. So, then you can find out x squared plus y squared as x squared minus y squared whole squared plus 4x squared y squared whole to the power of half. So, you have got x squared minus y squared and x squared plus y squared. So, from this x squared plus y squared are obtained, and then you can obtain x and y. So, then similarly, suppose x minus y is given and x y is given. So, then x plus y is b squared plus 4c whole to the power of half, and again you can find out x and y by Sankramana. Similarly, given x plus y and x y also, similarly you can do that, and suppose x plus y and x squared plus y squared are known, then x minus y is equal to this quantity, and you can solve it by Sankramana. So, then he discusses the solution of quadratic equations. So, this is how what he says: Rupotta hata padagre syatamantara vadhau tatasthabhyam pragvat yogaha sadhyah syatam sankramato rashi shayage mule nalpam tatkruti rashihi. Pada and agra divided by Rupottha happen to be the so called difference and the so called product respectively. Calculate the sum from them by the methods earlier. The numbers are obtained from them by the method of concurrence. In case pada is negative, the greater of the number is to be taken. The square of that is a number. So, whatever he is doing, the Sankramana thing, it is leading him on to the quadratic equation solution. So, what you have to do solve is, I had already written down equations like this in my previous lecture. Ax plus b root x is equal to c. So, a is the Rupottha, a is called the Rupottha, coefficient of x, b is the pada, coefficient of this root x, and c is called Drishya, when it is seen. Now, find b by a and c by a, and suppose the root of the equation is root x. Now, consider an auxiliary quantity root y. When b is negative, that is b is equal to minus mod b, in this case root x minus root y is equal to this, and root x into root y is equal to c by a. So, then this is not the other root, this is not the other root, it is somewhat different. He is trying to use the thing. So, you to find these quantities. Similarly, so then root x plus root y he has given, you see root x minus root y is this, then root x plus root y will be, he is giving this. So, finally, root x is mod b, here b is negative. So, minus b plus square root of b square plus 4ac by 2. So, in this root x is a greater quantity out of root x and root y. When b is positive, it is implied that this is the solution. Again, they will have the same form, is they are expressed differently. Here please note that instead of minus 4ac normally plus 4ac comes, that is because c is in the other side, you see. See, normally you have got ax plus b root x, ax squared plus bx plus c is equal to 0. So, here if you transfer it, it will become minus. So, that is why that is coming like this. Okay. At least here he is talking only one root, but I will point out that later he does talk about two roots, some problems he does talk about two roots. He wants this the thing to be positive. So, root x is the correct solution, using the modern standard way. So, various interesting problems are discussed. आकर्ण्य ध्वनिमद्रि मूर्ध्नि शिखिनोद्दानां स्फुरद्विद्युतां वृन्दार्धा त्रिलवौ तदंतर चतुर्भागैः त्रिभिः संयुतौ अद्यैर्देक पदादिकौ ननृततुः प्रीत्याप्त वृंदौ सखे जातं तत्र शतत्रयं प्रवद मे तत्पूर्ववृन्ते कति. So, a group of peacocks along with its half, its 1/3 and 3/4 of the difference, together with 1.5 times the square root of the group, standing on top of a mountain and hearing the thunder of clouds, surcharged with electricity, or dancing with joy. So, the peacocks are 300 in all. Oh friend, tell me the number of peacocks in the earlier group. I mean, whatever is left, dancing around, that is 300. So, you have to find the final number. So, it is always written in a nice example, which is amusing and which is pleasant to hear these things. So, suppose x is the number of peacocks, he says that, right? What does he say? Along with its half, right? Along with its half, Purad Vidyutam, okay. Then you also take 1/3, okay, 1/3 also you take, then 3/4 of the difference of this, that also you take. All these things you multiply by this. So, then 3/2 times the root x, he says, together with 1.5 times the Adyardhaika Padadikau, okay. So, that is there, 1.5 times the square root of the this thing, that is there, and finally 300, the total is 300, what is left after all this, that is 300. So, what is the I mean total is 300 and what is left is we have to find, that is the thing. Sorry, I didn't maybe the peacocks are 300 in all. So, initial number you have to find, initial number how many are there, that is what you have to find. So, this is the equation. So, finally you get this. So, if using this you get root x is equal to 12 and x is equal to 144. So, if x is equal to 144, so if you do all these operations, take this x and then half of it again you take and all these things you take. And what is the initial number? So, that is 144, which is less than 300. This was, sorry, this must be, this is x.
No, next to next line. Below that, x is missing.
That is missing, correct. 40, it must be 47 by 12 into x, correct, yeah, plus root x. So, this is the final quadratic equation, x you have to supply here, yeah, that is right. Okay. So, then he talks about quadratic equations involving successive remainders. So, this is also very interesting. So, the rule itself is very simple, very short. Ukta niji vidhe vadantya shesha vidhau jayate rashihi. Starting from the end, by the method stated earlier, the process on being performed on the remainders gives the number. So, of course, if you just read this, you will not be able to understand. What he is trying to say is the following. You see, suppose you have x minus a root x, let us say, and then take the square root of that. So, some such things may come, such things may come in some problems, So, x minus a root x minus b into square root of this, that is given to be something. So, are more complicated things, which I will consider soon enough. So, this is solved by putting, see, if you just put this is equal to y, so then y minus b root y is equal to c. So, you solve for y and then you have to solve for x from this. After solving from y from this, you have to plug in this y and solve for x. So, this is he is giving an example. Kantayaha surata prasanga samiye bhinna cha muktavali muktanancha padadvayam vicharanam shayya patasyopari tat sheshasya padam tribhaga yugolenadhyam priyena hrutam tat sheshasya padam kshito nipatitam sutre dvayam kim vada. Okay. So, during the amorous tussle playful quarrel or whatever. So, the beloved's garland was broken, that is important, pearls was broken, and twice the square root less 1/4 of the pearls were on the cover of the bed. Okay. Shaya patasya, this thing, So, that is the square root of less than 1/4 that was there, and square root of the rest along with 2/3 of this root were seized by the lover. Tat sheshasya padam tribhaga yuga lenadhyam priyena. You see. So, he took this thing and then the rest fell on the ground and 2 pearls were remaining in the string, you see, on the. So, she is wearing a garland of pearls, so it is broken. So, we have to find out how many pearls were there. So, on the cover of the bed, so it is 2 minus 1/4 into root x, and that is, you write it as 7, okay. Well, sorry, you write it as y. So, now remaining is x minus y, initially was x, we do not know that. Then the lower, he is seizing this, this one, he is taking the square root of this plus 2/3 times this, okay. So, that also we do not know how much he has seized. So, that you call it as z, and after these things, so at x was the initial number, y is on the cover of the bed and z is caught by the lover, and so remaining is x minus y minus z, so root z prime, okay. And what is on the earth? So, this root of this, on the earth root of z prime, so that is there on the earth which has fallen on the earth is square root of this remaining, whatever is remained after the lover has taken there. So, he has caught hold of these things, and after all these the remaining on the string is 2. So, you have to find out the original number of pearls. So, this whatever is remaining on the earth, that is root of z prime you have written, plus whatever was on the cover of the bed, that is y, whatever was caught hold of by the lover, that is z. So, root z prime plus y plus z, and 2 was remaining on the garland of the lady herself. So, that is 2. The total of that is equal to x, that is the original number of pearls. So, root z prime plus 2 is equal to, now if you shift it to this side, x minus y minus z is equal to z prime, okay, it comes. So, now you solve for z prime. So, you will get the solution as 2, root z prime is 2, so z prime is 4. So, now x minus y minus z is z prime, and z is, you have already given 5/3 root of x minus 5. So, x minus y minus 5/3 root of x minus y is 4. So, you solve for x minus y, x minus y will be 9. Now, y is equal to 7/4 root x, that is also given. So, x minus y, that is x minus 7/4 root x, that is equal to 9 from this. So, you solve for x, root x will be 4 and x is equal to 60. So, these square roots are coming in successive steps, more and more square roots. So, that is interesting, you can carry on like this. So, then again some remainder type of equation, Rupotagnat diagram yojyantyagre vidhi pragvat, multiply the Rupota by the first remainder and add the product to the last remainder, like that. So, essentially he is referring to an equation of this form, x minus a. So, then fraction of this and subtract it from this, then fraction of this and subtract it from this, like that. Finally, you are having this kind of an equation, x into some quantity minus j into root x, a into some quantity plus d. So, he is giving the solution for this. So, if you take up an example, then it will be clear. Ganesham padmena trinayana hari brahma dinapan vilomaihi sheshamshaihi vishaya lava purvaischa kamalam padena pujyaikena cha guru padam bhoja yugalam sarojena chakshva druta makilam ambhoja nichayam. Ganesha was worshipped with one lotus flower, Padmena. Shiva, Hari, Brahma, Dinapan is the maker of day, that is sun, were worshipped with 1/5, 1/4, 1/3 and 1/2 of what remained successively. Vilomaihi Sheshamsaihi, you see, successively. Kamalam Padena Pujya, Kamala was worshipped with the square root of the lotus flowers in the beginning. Ekena cha Guripadambhoja Yugalam Sarojena. The 2 feet of the teacher resembling the lotus flowers were worshipped with one lotus flower. Drutamakilam Amboja Nichayam. Quickly say the number of lotus flowers in the collection. So let x be the number of lotus flowers. So Ganesha is worshipped with 1. Okay. So the remainder after that is x minus 1. Then Shiva was worshipped with 1/5 of this. So 1/5 like x minus 1. So after worshipping Ganesha and Shiva, what you are left with is x minus 1 minus 1/5 into x minus 1. And Hari is worshipped with 1/4 of this. So after worshipping Ganesha, Shiva and Hari, what you are left with is this x minus 1 minus 1/4 x minus 1 minus 1/4 this thing. Okay. So Brahma is worshipped with 1/3 of what remains after worshipping Ganesha, Shiva and Hari, 1/3 of this thing. So after worshipping these 4, okay, what is remaining is this, and Sun is worshipped with half of this. So after worshipping Ganesha, Shiva, Hari, Brahma and Sun, so R4 minus 1/1 these things. Okay. And Kamala was worshipped with root x, and remaining is 1. Okay. So what you are getting is this kind of equation, x minus this, you will get this equation. You have to just be a little patient, that is all, nothing more is required in this. So you get this kind of an equation. So I mean this is precisely the form that he is discussing in his, as a solution. So you get x is equal to 6 by solving this quadratic equation. Finally you end up with that, and root x is 6, so x is 36. So another type of quadratic equation he discusses this kind of a thing. So they are all very straightforward. I don't want to discuss this. So he gives an example of this. Okay. So then he talks various double equations of second and higher order degree equations. So some of them were discussed earlier also. See, for instance, if you have x squared plus y squared plus 1 is equal to u squared, and x squared minus y squared plus 1 is equal to v squared, must also be a square. X is equal to m squared by 2 and y is equal to m, that is the solution. And suppose this is equal to u squared or v squared, this one. So then the solution will be this kind of a thing. And the solution of x plus y is equal to u squared means it is a square of a number, x minus y is again a square of an integer, and x plus y plus 1 is again a square of an integer. So the solution will be this. So like that is so on, he goes on. Particularly important is the various things, they are not trivial at all, you have to go through this. So next he goes in a one systematic set of equations which have got these integral solutions. Ghanayuti bhakte kruti yuti yuti kruti ghata hate tvishte ghanayuti yuti ghanatulya kruti yuti yuti kruti vadam rashyoho. Of course it sounds also fairly interesting. So the translation, without going through this, I mean we can go through this, if you take the slides. What he is saying is the following, see, what we are having is, so you have two numbers x and y, you have to have solution of x cube plus y cubed is equal to x squared plus y squared. Okay. So you want to find rational solutions for these, not trivial, not at all trivial, right. So it is given, if you take m and n to be any integers, then this is a solution of this equation, and x cube plus y cubed is equal to x plus y whole squared, and x cube plus y cubed is equal to x y. So then if you take any integers m and n, and if you take this x and y like this, then you get this kind of a thing. So ghana yuti yuti ghana, you see ghana yuti is sum of the ghanas, cubes, yuti ghana is the cube of the sum. So that is the kind of thing he is doing. So similarly the solution of this is integral solution, you will be having this kind of a form, and lastly x plus y whole cubed is equal to xy. So, this is the kind of solution you will have. Okay. Then he discovers consider the rule of inversions and all this rule of proportions and all that in great detail. So, I will not have time to do this. And the rule of proportions also, we have got some very interesting things, mixed quantities and various proportions. You are lending money at various interests, and suppose you are giving, many people are giving, then suppose their principal plus profit is equal, then what is the proportion, what is the ratio in which they are lending money. So, they are all very interesting problems. So, I do not have time. So, I will one particular, maybe I will take up one or two these things. See, suppose interest problems, let principals capitals P1 and P2 be lent out for time T1 and T2 months at the same rate of interest, and let the corresponding interest be I1 and I2. Then out of 7 quantities P1, P2 or T1, T2, I1, I2, 2 can be determined from the sum of them and the other 4 or considered as fixed. So, that is a very interesting way of this generalization of direct interest kind of calculations. So, what is happening is that, so what the rule says is any one sum out of see, suppose that this principals P1, P2, the time for lending is T1, T2, the interest out of them is I1, I2. Okay. See, suppose you are given any one sum out of this I1 plus I2, T1 plus T2, P1 plus P2, P1 plus T2, P2 plus T1, I1 plus T1 or I2 plus T2 or I1 plus P1, I2 plus P2 is known. The rest 4 ingredients are known. Then 2 comprising the sum can be found separately. See. So, I mean, these are all clearly this is where the mathematics has reached the stage where they are doing some things which are not directly relevant. You see, nobody will give the sum of the principal and time, but to see that generally how one can solve this problem using mathematical prowess. You see, so you should have the mathematical prowess to solve this kind of equation. So, that is why he is trying to solve this kind of equation. See, suppose you are given I1 plus I2, P1, T1, P2, T2. So, you have to find I1 and I2 separately. Okay. So, you are given the principals and the time lent corresponding to these they are given, and the sum of the interest is given. Then you have to find I1 and I2. So, then you use the fact that they are lent at the same rate is the same. So, I1 is P1 T1 R by 100, I2 is P2 T2 by R by 100. So, I1 by I2 is this, and finally, so you get one equation in terms of I1 and I2, I1 plus I2 by I2, this is the equation. So, the I1 plus I2 is already given, you will have one more equation involving I1, linear equation involving I1 and I2. So, you can find them separately. So, that is what is done. See, for instance, he says the sum of interest masena shatasya kriyat shashter varshasya yat phalam phalayoho yoge chatvarimshad rupayutam me phalam kataya tabhyam pakshadvitaye mito vimishre prutak krute bruhi. The sum of the interest of 100 in a month added to that of 60 in a year is at the same rate is 41. So, tell me the interest separately, you see. So, suppose P1 is given, P2 is there, T1 is 1, T2 12, and I1 plus I2 is given. Okay. See, suppose you are given posed like this, I am sure most people will be flustered, and they are all simple principles, but still you have to use this logic and all that. So, you use these equations, you get one more equation in I2, you will find that I1 will be I2 will be 36 and I1 will be 5. So, similarly, if any of these other quantities P1 plus I2, P2 plus I1, T1 plus I2, T2 plus I1, P1 plus T1, P2 plus T2, they are known, sorry, there might be a comma here. So, then also other things can be determined. Okay. Some of them will involve some quadratic equations. Okay. See, for instance, you are given P2, T1, T2, I1 and P1 plus I2. So, you have to find out P1 and I2 you have to find. So, I1 by I2 is this, remember the rates are equal. So, you get P1 I2 is equal to I1 P2 this thing. So, from this you can find out P1 minus I2, right. If P1 I2 is this, then P1 minus I2 is this, square root of P1 plus I2 whole square minus 4 P1 I2. This is a simple identity, you see, and P1 plus I2 is already given. So, you have found P1 plus I2, P1 minus I2 already knew P1 plus I2. So, P1 and I2 can be found by from Sankramana. So, this is the way things are done. So, intermediate steps, various kinds of quadratic equations etc. will come, one has to, or square roots etc. will come. So, these are the kind of things, he is giving some examples of that. So, now I think this is I found it interesting. So, I will discuss some payment in installments, which is discussed by Brahmagupta. So, we already see interest calculations, even in Aryabhatiya it is there, interest calculation is there, Ganidasara Sangraha it is there, of course Bhaskaracharya's Leela also contains. So, here also he contains, but as I told you, he advances it more. So, he will talk of payment by installments and what very close to this equated monthly installment, he will come to that. So, that is what I want to discuss. So, he says the capital is multiplied by the fixed period of installment is divided by the amount of installment less the interest. The quotient determines the time of being free from debt. So, this is what is this verse says. So, suppose the amount lent is P, the amount of installment is A, okay, and period of installment is number of months per installment, you see. So, he may be given once in 2 months or once in 3 months or whatever it is, that be T, and that the total time for being free from debt is capital T, NT let us say, okay. So, then in this case, say interest per period of installment is I prime and interest for total duration of debt is you have to multiply by n, okay, n installment periods are there, n into I prime. So, the amount due after time T is P plus Ni prime, right, n installments, and I prime is the interest per installment which we have calculated, which the lender is specifying, and the amount paid is Na because he is paying n installments of A each. So, P plus Ni prime is equal to Na. So, n, the number of installments is given by Nt, the Pt by A minus I prime. So, this is what is stated in the rule, okay. So, here everything is simple interest only, compound interest is not coming. So, this is how you calculate. This of course is simple enough. So, some examples are considered for this. So, again you can go on like this. Now, he will discuss a more realistic computation. See, here you are paying in installments, okay. See, your principal is P, okay, and your total, see, you are paying it in n installments, okay, you write it like this, of A each, okay. So, total interest you have paid is equal to this n into n amount per installments Ni prime kind of a thing, okay. And finally, you are giving P plus Ni prime. So, P plus Ni prime you are giving principal plus the interest, but you are not paying at the end, you are paying it in installments. In the beginning itself you are paying, you see, here you are paying 1 by n of this and so on, So, that means you are not getting any benefit for paying it earlier, okay. Suppose 5,000 rupees you have taken a loan and suppose 10% interest, okay. So, then after 1 year, so you have to pay 5,500. Suppose you are paying 5,500 by 12, every month. See, then you are losing, because you could have paid 5,500 rupees at the end, and you could have done something with your money. So you are not getting any benefit from paying earlier in installment. So that is what he is considering now. Okay. So he says, so this, the rule, next rule contains, pertains to the installment amount being adjusted only towards payment. He is considering only installment amount adjusted towards payment of capital. He has to pay the interest also. The rule gives expression for the amount of interest to be paid in addition to monthly installments being paid to clear the capital. So let the amount lent be P, the installment amount is A, and installment period is T months, okay, and the rate of interest is T or interest or percent per month. So if the amount is cleared in n installments, so P is n prime A, where n prime is P by A, okay, P by A. So one, sorry, rate of interest is if the amount is, no, it should be sorry, NA only. Okay. No, if the amount is cleared in n prime installments, okay, so this must be n prime. Okay, I am giving prime so that it may not be an integer. Okay, if the amount is cleared in n prime installments, P is equal to n prime A. Okay, to emphasize that it may not be an integer, I am putting it as n prime. So n prime is P by A. Okay, so this A is only for payment of principal. Interest is separately paid. Okay, so this is a different problem he is considering. The interest is separately paid, but A is paid only to clear the principal. So total time for being free from debt is n prime into T. So that is Pt by A. Okay, suppose T installments is clearing. P is the n prime is the number of installments, and installment period is T months. So total time is n prime T. So n prime is P by A. So it is Pt by A. Total, this is the total time. So n prime need not be an integer. That's what I wanted to say. N prime is n plus, let's say, f by A. N is an integer. No. The number of installment, which is a fractional number.
In fractional.
Yes. That's what I am coming to that. Yes. So n is integral, okay, and n prime is fractional. That is, he may take 2.5 months or 2 months and 1/10 of a month to clear. So that is allowed. Yeah. N prime is n plus f by A. You write it like that. So P by A is this. So P is NA plus f, where f is less than A. Okay. The principal is n into, it is where nothing. P is n prime A. N prime number of installments, A is the installment amount. N prime is not an integer. So which I write as NA plus f. Okay. So consider the amount P as made up of NA and f. Consider the integral part NA first. You see, n is integer. So at time T, installment amount A is being paid. Okay. So this is the installment period. So here A is paid. Okay. So then the interest should be the entire amount. The amount of interest now he is expected to give for this is n, because the whole money is there. You see, here whole money is here. I will talk about other part of principal separately. So you have to give the interest for the whole thing. So interest at time T, that is at the first step, is NA into RT by 100, because and now at this stage an amount A is already paid to clear the principal. Amount A is paid to clear the principal. So the amount due at the beginning of the second installment is NA minus A or n minus 1A. So at this time the principal owed, see, it is n minus 1A. So at the time of next installment you have to calculate the interest for this. So at time 2t we have to calculate interest for the amount n minus 1A. Remember that T is the amount period of installment. Okay, T is the period of installment. Okay. So interest at time 2t is n minus 1A into RT by 100, and similarly you can go on at some stage R. Okay, after R periods of installments are this thing elapsed, So then it will be n minus r into a, that is the amount of principal which is owed by the debtor, right. So interest at RT is n minus r minus 1 rather, okay, because this is the first full thing is this thing. So r minus 1 you have to put. So this is the amount which is owed. So that you have to calculate the interest for this, okay. So n minus r minus 1 into a into RT by 100, and interest at time nt, of course after that, you know, he is this will be just a at this point, you see, at n, okay. So only a will be left here, that is the amount principal which he has to this thing. So that is all will be cleared there, okay. So it is RT a into RT by 100. So total interest for the integral part, I am only taking the integral part, you see. So P is the, you know, remember P is n prime a is n plus fraction into a. So that is how we discusses it. So total interest for the integral part is n plus n minus 1 etc. up to 1. So you are getting the arithmetic progression here. So n into n plus 1 by 2 into a into RT by 100, and end of duration nt. See now after the duration the principal due is f. Sorry, this must be NA plus f. NA plus f. You should write it like this. So after this is still left. So for that you have to pay the interest also. This will be cleared in time f by a t, but the debtor has to pay the interest for the entire period for this, you know, because this we did not include in this calculation. We had only considered the integral part. We have to pay the interest for the whole thing. The total interest to be paid is n into n plus 1 by 2 into a plus pf by a into RT by 100. So this n is called the pada, f by e is called agra, and this quantity is called moola pinda. So this is the amount he has to pay apart from the money he has given to clear the principal. You see, at every installment he is giving, he has to give this interest. Of course he does not specify when this interest will be paid, maybe every month it will be paid, you know, in installments. So this is the thing. So here is the number of installments, you see, after this, because a is specified, so the fraction, so this is a fractional month, you know, so this is a fraction. The whole thing is cleared in a fractional number of month, integral plus a fractional number of this. So that is precisely what is, now this is a rule that is there, skandaka bhaktam vittam labdam padasamnakam cha visheshamsha etc. So what he is saying, the amount or capital principal lent is divided by the amount of installment. The integral part of the quotient is called pada, the remaining part is called agra, so on and so forth. You just have to, this is what you have to, what is, yeah, this is the thing, total interest is what you have to remember. This is the formula, and that is expressed in the verse.
So pada is the periodicity of the installment.
Yeah, pada is the, yeah, that's right. N is pada, periodicity, yeah. The total number of this, you know, the integral part of this number of installments. So that is pada here. Yeah. So you are given an example. So then, so now we consider a little more than this thing of this. So here he is paying, see the amount A he is paying per installment, that is only for clearing the principal. The interest he is doing separately. So that is why we did this thing, you know, whatever amount of principal he has to pay, that we have considered, and then interest we have calculated separately. So now he does take the thing also into account, whatever amount is A he is paying, so that is partly towards principal and partly towards interest. So that is what he is considering next. We consider the case when the installment A is the interest and the outstanding amount plus the payment of a part of the principal. So in the following rule gives the time of being free from debt. Pratimasika phalashuddho moolam moolat pruthak pruthak jahyat शेषस्य मासिक फलं विशोधयेत् मासिकोपनयात् शेषाणानेन मूल विशेषमाप्तं तु मासयुक् कालः. Subtract the principal part of each monthly installment free from the capital successively. This gives the number of complete months and the residue of capital if any, and subtract the interest of residue due for a month from the amount of monthly installment. Divide the residue of the capital by number. The quotient added to the number of complete months is the time of being free from debt. What is he trying to say? See, let the amount of principal be A, rate of interest is R percent. So, you call R prime as RT by 100, T is the period of installment. At the time of first installment, interest due is R prime P, right? P is this thing, and monthly installment is A, and principal part of monthly installment is A minus R prime P, because interest is this, principal part is this. So, amount due after first installment pay is P minus this. See, you have paid this P, and then you have calculated the principal part, how much you have cleared, you know, that is given clearly by this. So, this is P1 is this, then the interest for this at the time of the second installment is R prime into P1, not R prime into P, and amount paid is A. So, then you have to find principal part, whatever is paid, you know, principal part of the monthly installment is A minus R prime P1, and amount due after payment of second installment is this, and amount due after payment of n installments will be this kind of a thing, you know, some kind of a geometric progression will come. According to the rule, we go on till R is equal to Pn is less than A. R is the remainder of the residue he talks about. So, it takes less than an amount of period to clear R with its interest, okay, because this is less than A. So, amount of installment, you know, if it is full installment period, you know, you have to pay A, but only a small part he has to pay less than A. So, that is all those things can be calculated.
Sir, in that the principal is P or A?
Which is P is principal. Sorry, principal is A, and I should have put it as P. Amount of principal is P actually, correct. A is the same as P. I used it here, I did not use it afterwards, yeah. P is the principal, yeah. Okay, that fraction can be calculated. If we give an example, then it will be very clear to you. See, Narayana's concept of installments is very similar to the modern concept of equated monthly installments. The only difference is that in modern times, the time for clearing the debt is fixed, okay, and of course compound interest is there. Time for clearing the debt is there, and then you fix the this thing, equated monthly installment, you see, based on compound interest. Here, the amount of installment is fixed, and the time is being this thing, you know, calculated, and taking into account the fact that of course compound interest he does not talk about, but still it is, you know, whatever amount you are clearing, that has been, you know, taken into account, okay. So, are giving relief for that. So, it is realized that, you know, principal is, you know, being clear. So, if I give an example, it may be slightly, sorry, we are run out of time, let me do it. A rich man lends somebody 100 at the rate of 10% per month. The debtor gives a monthly installment of 50 including interest. Oh friend, tell me the debtor's time of being free from debt. So, P is 100, the rate of interest is 10, okay, 10% per month, high, but anyway. So, A is 50 amount of installment. So, at the time of first monthly installment, interest is 100 into 10, 1 by 10, right, that is how this thing he is paying. So, 10, so payment is 50. So, he is clearing the interest of 10. So, payment towards principal part, so the rest is payment towards principal part 40. So, amount due after first installment is 100 minus 40 is 60, okay. So, you get the point. So, after this thing 100 he has taken. So, after one period of installment, 1 month, 10, you know, is the interest. So, he is paying 50. So, if you subtract that 10, okay, so 40 he has paid for specifically for clearing the principal. So, principal now will be new principal. So, that will be equal to 40, sorry, 60, yeah, okay. And interest for this month, you know, for 1 month, that is 6, okay. So, after 1 month, So interest will be 6. Okay. So in that case the payment is 50. Okay. So the payment towards principal is 44. Okay. So that is 644. So how much is left? So the 6 only is left. Okay. That sorry, yeah, 44. Yeah. So the amount that is left is 60 minus 44. He was so 44 he has paid towards principal. 60 was what was owed for the principal. So 16 is left now. The new principal is 16. So he owes, he has to pay a principal amount of 16 at the end of 2 months. Now 16, it is less than 50. Okay. So interest and R is equal to 16 for a month is 1.6. So fraction of the month is required to clear this debt with interest R. So the fraction of the debt one can find out. So that is 4 divided by 12.1. You see. So after this is the fraction of the month required to clear the debt. You see. See after this only this fraction 4 by 12.1 1 month is required to clear the remaining principal amount 16 and the interest on that. So that is taken care of this in the denominator. So if you go through this it will be. So that is how he has done this. So in everything, as I told you, it is some more advancement is there and some more generalizations and some new methods and new principles are. The references are given here. Thank you.